Kia ora, Year 13 and Year 12. This is the first question that we looked at in today and yesterday's scholarship calculus session. So I'm trying to put off writing a report comment, so I thought I'd do a scholarship calc video instead. This is the question in which we're asked to find the minimum value of this function here. And there are two ways to do it. The first one is using calculus, and the second one is using a really cool thing called the AM-GM inequality. So in this video, I'm going to go through both of those pretty slowly. Make sure that you have a pen and paper with you while you're watching, and try and do it before I start working through it. Okay, so firstly, looking at how we'd minimize this using calculus, we've got a function and we've got a log to base m, and we've got a log to base x. Now the only log that we're going to find really easy to differentiate is going to be this one, which is y is equal to the natural log of x, which is log to base e of x. So the first thing I'm going to do is change both of those logs into log to base e. So let's start off by doing that. Remember, when I change the base, I take the new base, so log to base e of x, and then I divide through by log to base e of m, and then I'm going to do the same thing here. I want to have log to base e, so it's going to go like that. Okay, so that's step one. Now we're going to write that as natural log, and then we're going to differentiate. So all of that is pretty straightforward chain rule. So pause the video here and go and do those steps. Right, so rewriting that function with ln before we differentiate, this is what we've got. We start with that. Here we have 1 over the natural log of m, that's just a constant, times 1 over x, plus, going to use the chain rule here, so it's going to be minus log m times ln x to the negative 2 times the derivative of the inside function, which is 1 over x. Sorry about the background noise. So here we've got x log m minus log m over x log of x squared. Now, for a minimum, we need to have the first derivative is equal to 0. Remember, when you are answering scholarship questions, the little wordy stuff like this is really important, because it shows why you're doing each step. So do make sure you write down something like that. So that means I have to solve this equation. Cross multiplying, we get this. Just be careful that you don't decide to do this, because that would be really bad, because you're going to lose a solution. Now it turns out that actually we don't end up having x equals 0 as a valid solution anyway, but we don't want to jump to that conclusion just yet. So cross multiply and now subtract the right hand side from the left. So do the next couple of steps from here. Right, so hang on, black pen. Right, we should have this x times the log of x squared minus x times the log of m squared is equal to 0. Take out the common factor of x, and now I've got the difference of two squares. So this is going to give me three possible solutions. And we're going to look at each of those and then decide whether we accept or reject them. Okay, so the first one is going to be x equals 0. The next one is going to be that log of x plus the log of m equals 0. So the log of x is equal to negative log of m which is the log of m to the -1. I'm doing this really slowly because I did this quite fast today, a bit too fast. So there we go. So now we've got the natural log of x is equal to the natural log of 1 over m, which says that x is equal to 1 over m, might be a solution, so we're going to come back to that one, and this one. And here, we've left out a natural log there, sorry about that. We've got the natural log of x is equal to the natural log of m, which gives me x equals m as a solution. So let's have a think about what our conditions were. Well, we had to have x is greater than 1, and m is fixed and also greater than 1. So this solution is fine, no problems with that. This solution is not fine, so we reject since 0 is less than 1. And this one here, m is greater than 1, so 1 over m is less than 1, so we reject this because 1 over m is less than 1. So that's not a solution, that's not a solution. So we've just got one solution. Now in the scholarship assessment schedule for 2012, they didn't require you to verify that you'd found a minimum, but I'm going to work through that and see how that looks. But remember, the thing we were actually asked for was not just the x value, but it was to find the minimum value of the function. So we now need to take x equals m and stick that back into f of x. So I'm going to do that on the next slide. Okay, so what was f of x? Well, if we go right back to the start, f of x was the log to base m of x plus the log to base x of m. And so when x is equal to m, this is what we have, which is 1 plus 1, which equals 2. So it's probably the first time you've seen 1 plus 1 is 2 in a scholarship calc exam, but there you go. So we found the minimum. As we said in this week's sessions, we're also going to look at how can we check whether it's a minimum. And we're going to do this not with the second derivative test, but with the little test we do of the gradient back in year 12 or in level 2.
Goodbye.
Okay, so what we want to do is we've got x is equal to m, and we know that the gradient there is 0. So to show that we found a minimum, what we want to end up with is this. We want to show that the gradient just below m is negative and the gradient just above m is positive. So that's where we're going. We're going to get rid of that. We can leave that one in. And we're going to manipulate the gradient expression to show that the gradient here is negative and the gradient here is positive. Alright, so what was my gradient expression? Well, we had f dash of x is equal to this. So somehow we want to play around with this to show that it's negative or positive. That's got a squared there. First thing we can do is pull out a common factor of 1 over x. When we're trying to minimize things, working with squares is good because we know that a square is going to be 0 or positive. So here we can see that that's going to be positive, so that's fine, but we really have no clue about what that is. So we can see we've got a log of x squared here. We can force in a squared thing up here if we do this. 1 over x times 1 over log of m. And that means here I've just got 1 now, and because I've timesed in 1 over log m, if I do this here, that all works fine. Right, now let's look at this. This bit must be positive, and now we can have a wee look at this. So I am doing this really slowly. I'm sure half of you have hit stop by now, but if you're still watching, we'll look at what's the sign of this part of the expression going to be now. So this is equal to 1 over x log m times 1 minus log of m over the log of x, and we can write that as all of that squared. Okay, so now let's go through the two cases. The first one is that when x is less than m, we've got the log of x is less than the log of m. So the log of m over the log of x is going to be greater than 1. And also, the log, this is a bit dodgy, but we'll just do that anyway. So there, the log of m over the log of x squared is also going to be greater than 1, which means that 1 minus that thing is negative. And we know that this is positive, so that tells me that f dash of x is negative for x below m. Okay, so there's x, and oh whoops, sorry, that's m, and that's a little bit below m. The gradient here is negative. Right, and you can finish off the argument here. This video is far too long already, so do this again. For on this side there's m plus epsilon. When I'm a little bit above m, this works out to be positive. So I've found a minimum. Okay, as we said, you don't need that for this question, but that may come in handy somewhere else, you never know. Now, because this video is so long, I'm going to do a part 2 about how to do this with the AM-GM inequality. So thanks for watching. If someone could please tell me if the sound quality is okay, either in a comment or just by emailing me, that would be great. Thanks very much.